Hey guys, here are notes for Unit 6, Sections 5 and 6. Just a couple of short sections, only 6 slides, and they're pretty quick, I think. I'll go through them pretty quick. You can always pause it when you need to. On Unit 6, they're talking about the special parallelograms. Now, a rectangle, a square, and a rhombus are parallelograms because all three of these have opposite sides being parallel. So we do know that these are definitely parallelograms. So a rectangle, you've got a shape like this where you can see the top and the bottom are parallel, the sides are parallel. A square, you know that the top and the bottom are parallel and the sides are parallel. In a rhombus, you've got opposite sides parallel. So rhombus could have different shapes. It's the key thing is rhombus has 4 equal sides. Now here are the characteristics for each one. And let's go through the rectangle first. Characteristics of a rectangle. The definition, it's a parallelogram that has 4 right angles. Rect really is for right angles. So rectangle is right angles. So that's the definition. Characteristics, the diagonals are congruent in a rectangle. So if I was to draw a diagonal across here and I was to draw a diagonal across here, they would be the exact same length. Diagonals in every rectangle are congruent because of the right angles. The right angles makes the diagonals congruent. Here's a picture, and you can see that diagonal AC is congruent to diagonal BD. Those are the congruent because they are right angles. All right, next we'll do the rhombus because we're going to come back and get the square. So the rhombus definition is a rhombus is a parallelogram with 4 congruent sides. So a rectangle has 4 right angles, means 4 congruent angles, all right angles. This one has 4 congruent sides, so all 4 sides have to be the same. It doesn't matter about the angles in this one. You just have to have 4 equal sides. Characteristics, there's a few for the rhombus. In every rhombus, the diagonals are perpendicular. Now it doesn't say that they're congruent. That's for the rectangle. The rectangle is where they're congruent. In a rhombus, the diagonals are perpendicular. They're going to make 90-degree angles. And in a rhombus, also the diagonals bisect the angles. That means if you were to draw a diagonal across here and a diagonal across here, it would cut all the angles in half. All the angles would be cut in half. And here's a picture of it. You can see the 2 diagonals. Now, you can see that they're not the same length because this diagonal is way longer because of the angles are pointed out here. This diagonal is shorter. But the thing is, it is a rhombus because it's got 4 equal sides, and the diagonals are making 90-degree angles. So they are perpendicular, and they're cutting all 4 angles in half. So you can kind of see the notations there. Now in all 3 of these, the diagonals are always going to bisect each other. So these diagonals will cut each other in half because that happens in every parallelogram, whether it is a rectangle, rhombus, square, or any kind of parallelogram. Now for a square, the reason I saved that last is because if you put the rectangle together with a rhombus, you combine those 2 together, you get your square. So the square it's a parallelogram, has 4 congruent sides like the rhombus and 4 right angles like the rectangle. So the characteristics, diagonals are congruent from here, diagonals are perpendicular from here, and the diagonals bisect the angles from here. So the square does both of these. The square, you just put them both together, you get the square. So that would be your 3 special ones. Now let's look at some other practice things. A kite. A kite is another quadrilateral. It's the other quadrilateral besides the parallelogram and the trapezoid and a kite. A kite has 2 pairs of consecutive congruent sides. So these 2 consecutive sides are congruent, and these 2 consecutive sides are congruent. It doesn't mean they all have to be congruent, just these top 2 and these bottom 2, you got a kite. In a kite, the diagonals are always going to be perpendicular. So you can see they will always make 90-degree angles in a kite. So that's one characteristic of every kite. And in every kite, the 1 pair of opposite angles are congruent. So here you can see that it's in this kite, it's this pair that are congruent. This angle is definitely bigger than this angle down here. Those are not congruent ones, but between the sides that are not congruent here and these 2 sides that are not congruent, you have your congruent angles. So you always have 1 pair of congruent angles. in a kite. Moving on to the trapezoid. These are just characteristics of a trapezoid. A trapezoid is another quadrilateral, and it has one pair of parallel sides called bases. So a trapezoid can only have one pair of parallel sides. If it has two pairs, then we know it's a parallelogram and not a trapezoid. So if it's got one pair of parallel sides, then it has to be a trapezoid. Now there are different types, but you can look at the key words here. The parallel sides are called bases, and the non-parallel sides are called legs. So you got base and base, you got your two bases. You can always have a short base and a longer base, because we know that these two aren't the same, so the top and the bottom can't be the same. And we have different types of trapezoids. We have what we call a right trapezoid. A right trapezoid is going to have two right angles, still going to have parallel sides, and it's going to have one that's not parallel to this side. So you can still see the bases are never going to be the same length. We also have what we call an isosceles trapezoid right here, where you've got two congruent legs. So you've got this leg AD congruent to this leg BC. That's called isosceles. Just like anytime you have two congruent things, you're going to have isosceles. So two congruent legs. In an isosceles trapezoid, the base angles D and C and A and B have to be congruent. So A is congruent to B and D is congruent to C because of the congruent legs. The base angles are also congruent. Just like an isosceles triangle, you would have base angles congruent. And the last part is that the diagonals are congruent. AC is congruent to BD. Now the diagonals are congruent because the angles are congruent on both sides. Just like when we had a rectangle where you had 90-degree angles on both sides, since the angles were the same, the diagonals were the same. So that's the same case here. We have angles, these two angles are the same as these two angles, so your diagonals have to be congruent. So that's a definition of an isosceles trapezoid, two congruent legs. Now we talk about a trapezoid that's got a mid-segment right here, middle segment. Mid-segment means middle segment. And it's when you connect two midpoints of the legs of a trapezoid. So this point right here would be a midpoint. So if I was to make a dot here, do that. This right here would represent a midpoint. You can see that this piece would be the same as this piece because that's in the middle. And then you'd have another midpoint on this side. That's another middle point. You got this top piece congruent to this bottom piece. It's a midpoint. Now, when you connect the two midpoints, you get what we call a mid-segment. It's a middle segment. That's all it is, because that's what the words are saying to us. Now, there's two things that this mid-segment does. The mid-segment in trapezoids are parallel, so it's gonna be parallel, just like we know the sides are parallel. So let me notate that real quick. They're parallel. So if I was to put an arrow here, and I was to put an arrow here, and I was to put an arrow down here, you would see that all three of those are parallel. The two bases we know are parallel because it's a trapezoid. The mid-segment is parallel to the two bases. So it's parallel to both bases, and they are the average of the two bases. So in other words, if I was to take 14 and add 20 to it, if I was to take the 14 plus the 20 and then divide it by 2, that would give me the average number. So that'd be 17. So halfway between 14 and 20 would be 17. From 14 add 3, you get 17. You add 3, you get 20. So 17 is the exact middle number. There, that would be the mid-segment. It's the middle number, and it's parallel. That's what we call a mid-segment of a trapezoid. Now here are some area formulas. Just side note, hopefully you have these printed out so you don't have to write them all down. But it's just good to know how to find the area of all these special figures. Square we know is side squared. Rectangle we know is base times height. Parallelogram is the same formula as a rectangle. It's just that you need to find the height at a 90-degree angle. So it's a base times a height wherever you can find a 90-degree angle. That's your base and your height. Triangle we know is base times height divided by 2. And we learned a new triangle formula when we did law of sines and law of cosines, but normally we just use our old faithful base times height divided by 2. For the area of a trapezoid, it's just like a triangle because trapezoid and triangle kind of sound similar. Instead of base times height, it's the bases times the height divided by 2. So we add the two bases, then times it by the height, then divide by 2. We don't even need this 4 for the area. What we're going to do is we're going to add the 5 plus the 8, that's my two bases, times it by 3, which is my height, and then divide by 2. So that would be my area of a trapezoid. Bases times height divided by 2. Think of triangle and trapezoid. Very, very similar formulas. To get the kite formula, you just take the two diagonals, diagonal times diagonal, and then cut it in half. So diagonal, this would be 4 plus 7, which is diagonal 1 is 6 because you got 3 and 3 together. Diagonal 2 is 11 because you got a 4 and a 7 together. So I'm going to take 6 times 11, the diagonal 1 times diagonal 2, and then cut it in half. I get 33 would be my area for that kite. And then for rhombus, it's going to be base times height. You could also use the kite formula because a rhombus will look similar to a kite. So you could actually use diagonal times diagonal over 2, or you could use the formula for a parallelogram and do base times height at a 90-degree angle. So for a rhombus, you really have to know that you can use both formulas because sometimes they give you diagonals and sometimes they give you a base and a height. So that's for your rhombus. And the last thing is we're going to fill in the proof. So let's read it over together. Alright, so let's take a look at it. It says, given that we have a parallelogram ABCD, so just the fact that this is a parallelogram that gives us a lot of information. It's telling us that these two sides are equal, these two sides are equal, opposite angles are equal, the diagonals would bisect, telling us tons of stuff just by this word parallelogram. They want us to prove that the opposite sides are congruent. So we know that they are because it's a parallelogram, but we're right now assuming that they're not. And we want to prove that they are. Prove that a parallelogram this actually works. So first we talk about ABCD being a parallelogram. That's my given statement. There's the little parallelogram right there. So second thing, we draw in line BD. We're allowed to draw any line through 2 points. If I have 2 points, I can always draw a line connecting them. That's something we're allowed to do. We're allowed to connect 2 points. That's the only line that I could draw from B to D. There's no other line that would connect B and D that's a straight line. Now, because of the word parallel, that means that the only way this could be a parallelogram is that these sides have to be parallel. So because they use the word parallelogram, that's going to be our definition of a parallelogram, is that the opposite sides are parallel. So that would be step 3. Opposite sides are parallel. So what we might even want to do there is put little arrows on our picture. I like to do things like that when I'm doing a proof. You like to put those things on there. So there would be one arrow that shows that they're parallel to each other. There's another one. I could do ones going the other direction. There. And another one over here to show that the opposite sides are parallel. That is the definition of a parallelogram. So number 4, we're going to show that these angles are equal. Angle ADB, which is this angle right here, is congruent to CBD, which is this angle right here. Also ABD, which is this angle up top, is congruent to CDB, this angle at the bottom. Now you might notice what they are. They looks to me like they're alternating sides of this transversal, and they're between 2 parallel lines. So if you remember, that would be alternate interior angles. That's why these are congruent. Now, DB is congruent to itself. That's step 5. DB is congruent to itself, and that's our reflexive property. So that would be reflexive. Now I can prove that these are congruent because I can put an A right there, that angle, and I can put an S right here because we have that side, and I can put another, oh, I had those already there, my bad. Let's do this. Okay, so I had these already in there for us. Oops. That one and that. Okay, so I can put an angle here for this angle. I can put an S, and then I can put another angle down here for this angle. And we have ASA postulate is what proves that these two triangles are congruent. So that would be my, oh man, I just lost it. That would be my ASA. I'll just have to type it in down here. That would be ASA right here. Now, because these two triangles are congruent, that means that this top piece has to be congruent to the bottom, and this side has to be congruent to this side, and we call that, it's still not working, we call that CPCTC. CPCTC. So that would be our proof. Corresponding parts of congruent triangles are congruent. Let me type that in for you. Corresponding parts of congruent, because we already proved that the triangles are congruent, So there is your proof. Shrink that a teeny bit so I can fit it in there. There you go. All right, I'll see you guys later.